Volcanoes are one of nature's most destructive forces. A single volcanic eruption can wipe out an entire city in an instant. Even worse, scientists believe that a supervolcanic eruption could destroy everything. So what actually happens when a volcano erupts? Is there anything we can do to stop it? And how might we even survive one? Welcome to our channel. And today we'll take a look at volcanoes, the hidden physics and chemistry that could destroy us. We tend to think of volcanoes as natural landmarks, like the Matterhorn or Half Dome. But although some volcanoes have been around for thousands of years, they're still very much active and dangerous. Just ask the people who lived near Mount Vesuvius when it erupted and destroyed the Roman city of Pompeii in 79 AD. In fact, volcanoes are so common that there are more than 1,500 of them dotted across Earth's surface. About 500 of these volcanoes are potentially active, and in 2021 alone, nearly 800 volcanic eruptions were recorded worldwide. Although many of these eruptions are relatively minor, others pose a serious threat to human life. For example, in 2021, the Hunga Tonga volcano in the Pacific Ocean unleashed an explosive eruption that was heard over 2,300 kilometers away. This event also triggered a tsunami and killed 4 people. But this is small potatoes compared to the largest volcanic eruption in recorded history, which unleashed more than 2,800 cubic kilometers of material. As dramatic as these events are, they don't even come close to the most powerful type of volcanic eruption, known as a supereruption. Fortunately, these are extremely rare. The last one happened about 74,000 years ago in Indonesia. But what exactly makes an eruption super? It all has to do with the Volcanic Explosivity Index, or VEI. This index is based on 8 different factors, including the volume of material ejected, the eruption height, and the duration of the eruption. Eruptions can range from 0 to 8 on this scale, but only eruptions of 8 are considered super. In fact, only 6 super eruptions have ever been recorded in Earth's history. The largest was the 1883 eruption of Krakatoa in Indonesia, which reached a VEI of 6. Super eruptions of VEI 7 or 8 are thought to occur only once every 50,000 to 1 million years. So we're probably pretty safe, right? Well, maybe not. One theory suggests that the 1980 eruption of Mount St. Helens in Washington state was actually a foreshock to a much larger event. Scientists estimate that the true eruption will reach a VEI of 8 and will eject between 300 and 400 cubic kilometers of ash and pumice. If this occurs, it would be devastating for the surrounding area. But would it affect the rest of the world? The impact of any volcanic eruption depends largely on 2 factors: the amount of material expelled during the eruption and the explosivity of the eruption. Let's start with the first factor. During any volcanic eruption, hot magma from deep inside the Earth's crust makes its way to the surface. As the magma approaches the surface, pressure decreases, which causes dissolved gases in the magma to expand. The magma becomes increasingly frothy and eventually turns into a mixture of solid rock, hot gases, and liquid called magma. When this magma reaches the surface, it's known as lava. How quickly this process takes place determines the type of eruption. If the magma is viscous or thick, it tends to trap gases and increases pressure. Eventually, the pressure becomes too great, and the gases are released in a violent explosion. This is known as an explosive eruption. Conversely, if the magma is runny, gases escape more easily and the eruption is less violent. This is known as an effusive eruption. Let's consider the 1980 eruption of Mount St. Helens as an example. On March, a magnitude 5.1 earthquake struck the mountain, causing a rock slide on the north side of the volcano. Hot magma rapidly ascended through the opening created by the landslide. As the magma approached the surface, pressure decreased and dissolved gases expanded. The resulting explosion obliterated everything in its path. Hot ash and pumice were thrown miles into the air, and solid debris covered the ground for hundreds of square kilometers. By the time the eruption ended, Mount St. Helens had lost more than half of its height, But what if the magma isn't trapped by a thick layer of rock? What if it can flow freely toward the surface? In this case, the magma won't explode, but rather spill over the land like a lava lamp. If this happens, the danger zone will be much smaller. But there are other dangers associated with effusive eruptions. For example, lava flows can travel long distances before they cool. They can also cause significant damage when they reach populated areas. During the 1707 eruption of Mount Unzen in Japan, lava flows traveled 8 kilometers down the mountainside and destroyed 25 villages. If you want to know how dangerous an eruption is going to be, you need to look at the VEI. The higher the number, the more dangerous the eruption. For instance, Mount St. Helens had a VEI of 5, which means that its explosive eruption column reached 15 to 30 kilometers into the atmosphere. The eruption deposited 3.5 cubic kilometers of material and lasted only about 3 days. These numbers may seem small compared to super eruptions, but keep in mind that Mount St. Helens was a relatively small volcano. A super eruption would deposit thousands of times more material and would likely kill millions of people. To prevent loss of life, scientists use a variety of tools to monitor volcanoes. They measure things like seismic activity, gas emissions, and ground deformation. By analyzing this data, they can identify patterns that indicate an impending eruption. For example, an increase in seismic activity could indicate that magma is moving toward the surface. A buildup of gas emissions could suggest that pressure is increasing within the volcano. And ground deformation could reveal that the volcano is swelling in size. When scientists detect these signs, they issue alerts so that people living nearby can evacuate. But what if a super eruption were to occur? There's no way we could prevent it because the amount of magma involved is far greater than anything we could remove. And although we might be able to predict it, there's no way we could stop it. Our best bet would be to evacuate the surrounding area and hope for the best. But even that wouldn't guarantee our safety. Solid debris ejected during the initial explosion would pose a threat to anyone who didn't get far enough away. Pyroclastic flows, which are hot mixtures of rock, ash, and gas, would race down the sides of the volcano at speeds of up to 160 kilometers per hour. Lava flows would destroy everything in their path, and intense heat would incinerate forests for miles. But there's another danger that's even more widespread: ash. Ash particles are incredibly abrasive and can damage everything they come into contact with. They can grind to a halt machinery, collapse roofs, and ruin crops. After the 1980 eruption of Mount St. Helens, ash fell over an area of 200,000 square kilometers. The fine ash traveled all the way to Canada and Alaska, killing thousands of animals and ruining millions of dollars worth of crops. Now imagine that this happened on a much larger scale, like the 1815 eruption of Mount Tambora. During this eruption, ash blanketed an area of 3,600 square kilometers and drifted all the way to Western Europe. The ash caused widespread crop failures and food shortages, which led to the deaths of tens of thousands of people. But there's one thing that's even more dangerous than falling ash: breathing it in. Breathing in large amounts of ash can cause severe respiratory problems. It can also lead to heart attacks and strokes. People who were exposed to the ash from Mount St. Helens experienced symptoms such as chronic cough, asthma, and lung disease. And the 1816 eruption of Mount Unzen in Japan killed more than 15,000 people, mostly from breathing in ash. In order to protect ourselves from volcanic ash, we need to wear masks that can filter out tiny particles. We should also stay indoors if possible and avoid touching our eyes and face. But what if we can't escape outside? What if we're trapped in a building when an eruption occurs? In that case, we need to find shelter in a basement or an underground structure. If that's not possible, we should at least stay away from windows and doors, because flying debris can easily come through them. Volcanic eruptions are truly amazing natural phenomena. While they can be beautiful to behold from a distance, it's important to remember that they're also incredibly dangerous. From the hot lava flows to the suffocating ash, there are many ways that we can be harmed by these eruptions. But by understanding the risks and taking precautions, we can keep ourselves safe and enjoy the spectacle from a safe distance. So what do you think? Are you prepared for a volcanic eruption? Let us know in the comments below, and if you enjoyed this video, don't forget to hit the like button and subscribe for more science explainers. Thanks for watching.